Hello guys, welcome back to the channel. And in today's video, I'm going to talk about this question: binary tree right side view. It's a medium question, LC-199. And if we look at the companies that have asked these questions, you can say there's a couple of companies this question has been asked in past 6 months also, and even before that this has been quite a lot of number. So I think this is a pretty good question to get uh, apply different kinds of traversals to binary tree. So without wasting time, let's get started. So the question says that you're given the root of a binary tree, and you have to imagine that, let's say, you're standing on the right side of the tree, and you have to return the value of the nodes you see ordered from top to bottom. So let's imagine that this is your tree, right? In the example, and you're standing somewhere here, okay? And when you look at that, towards that side, you see only the last nodes of the right side of the tree. So those last nodes you have to print starting from 1, that is your top, till the leaf, that is your 4 in this case. So in this case you will be seeing 1, 3 and 4, right? So you should print a list. Actually, you are returning a list, so you just return that list and keep adding that in the correct order. Similarly, if let's say there is this kind of tree where one is the root, then the left is the null, and the right is the three. So if you look at in this direction and then you say that, okay, what are the nodes that I'm seeing? So you will see one at the top, and then there is three. So you return one and three. And if there is no root, it is null. It's a null tree. So obviously you have to return blank. There is no list to be returned. Now, if you observe a little bit, you'll see that basically you are traveling level wise, right? At first level, you have to return the rightmost, then at the second level, you have to return the rightmost, then at the third level, you have to return the rightmost. So, if you observe it, it's actually going level by level. It's not that in any one direction you're going recursively till the bottom, right? So, this should give you an intuition that this is a breadth first traversal problem. Okay, BFS for a binary tree. So now if you know how to do BFS on a tree, then just a little addition to it on the top of it in terms of logic will help you achieve the solution. So let's try writing it, right? So first of all, whenever we do BFS, we need to maintain a queue, right? So I'll create a queue. I'm going to use Java collections. So queue is implemented using linked list in Java. So like this. Now, what is going to be the type? See, now this is the important thing. You have to keep the type as a true node and not an integer. Why? Because when you are adding into the queue, you'll also be popping into it and referring its left and right children. Now, if you are just storing integer, there is no reference to its left and right children, right? So that is why you need to store tree node. Okay. So let's have tree node here. In this case, it is since it's given tree node, so we'll add that. Some other question, maybe node, maybe something else, binary tree node, whatever, you have to add it here. Okay. Now, what do we need to do? I need to start adding my elements and then I need to traverse it, right? Now, before that, just one edge case that if my root is null, because it can be null, right? Like in this case, it was given null. So I don't have to do anything, right? So that edge case I can handle right away. So I'll say that if root is equals to null, I have to return this blank list only. So let's also make a list. Uh, let's make array list of integer, which is going to be a final answer, and this is integer type. Okay. So if your root is equal to null, you just simply return answer. Don't have to do anything. If the root is not null, you will come down to line number 24 and then you'll add it. So you add the root to your queue. Okay. Now this will be the steps that will follow will be the steps of your BFS traversal. So let's try doing it, and this is done using the queue. So while your queue is not empty, I have to do it. What I have to do, I have to first get like whatever is the size of the q. That would be your size q. Now, why did I keep the size of the queue? Because see, if every level by level I'll go, I have to refer to the node which is at the last index of that size. So if let's say I've added 1, 2, and 3, so after I've popped 1, 2, and 3 is there, and I want to go to the index minus 1, right? The size minus 1. So in this case, the size is 2. So my index would be 1, 2 minus 1. That is why I've kept it like this. So now what I'll do is I will write a loop which is going to make sure that till there, like how many elements are there or the node elements are there in my queue, till that I traverse it. So for I is equal to I less than size I plus plus. Then what I do is I get the first element, right? So tree node is front, and I get it from that. So that is q dot remove. So it will basically pop off the first element and return it to the front. Now I check, is this the required element? So I check that if my I is equals to size minus 1, that is the last iteration in this loop, then this is going to be the last most element in that level, right? The rightmost. Then I need to add it to the answer. So I'd add answer dot add, which one? I'm going to add front dot val. Okay. If that is not the case, what will I do? I'll definitely, this is not the part of my answer, but I have to traverse it so that at the lower levels I'm able to access the children of that node. So I'm going to make a simple check that does this node has a left and a right children. So I check if front dot left is not equal to null, then add front. Okay. If front dot right is not equal to null, add right. Sorry, I should have written left here. Yeah, कि front का left is not null, so add the left. Front का right is not null, so add right. Okay. Now, once I've done it, then again I'll complete the iteration. Then I'm out of this loop. I'll go to the queue is not empty part, and then I'll check the size and keep on doing it. Right. So after this is finished, you will be coming out of the loop, and you have to return answer. What is it saying? Cannot find symbol left. Okay. Front dot left is not equal to null, so add front dot left. Front dot right is not equal to null, so you have to add front dot right. Okay, this got accepted. Let's try submitting it. Great. So this is the solution for this question. I hope you enjoyed the video, and let me know if you have any doubt in the questions or you have any ideas on how could I have better explained this. But yeah, that's our Java solution for right side view of the binary tree. Thank you. Thanks for watching. Bye bye.